Welcome to the Deep Dive. Today we're taking a closer look at Azure SQL Database. We want to unpack how it can, really change the game for building data-driven apps. Basically how you can avoid a lot of those typical infrastructure headaches. Consider this your fast track to getting it.
That's a great way to put it. Azure SQL Database, at its heart, is a fully managed PaaS platform as a service relational database. It's built on the familiar Microsoft SQL Server engine, but it's designed for the cloud. Think scalable, secure, high-performance SQL. And the real key here, it simplifies things dramatically. It handles stuff like patching, backup, scaling, all that background noise. So you, the developer, can actually focus on building the app, not fighting fires with the database infrastructure.
Okay, let's rewind a bit. Before something like this existed, what were those major pain points for developers, for DBAs? I'm thinking high cost for hardware, right? All that manual upkeep, struggles with scaling up or down, and security being this constant complex battle.
Oh, absolutely. Those were, and honestly still can be, huge drains on resources. Azure SQL Database tackles them head on. Infrastructure management, mostly automated. Patching, backups, basic monitoring handled. Forget manually doing all that. Scalability was another big one. Here you get dynamic scaling for compute and storage. So if your workload spikes or drops, the database adjusts. You're not stuck over or under provisioned.
And availability, that's always crucial.
Exactly. It comes with built-in high availability. We're talking SLAs of like 99.99% up to 99.995%. Plus, geo-replication for disaster recovery, so your data can be safe even if a whole region goes down. And on security features like always encrypted, keeping data safe even during queries, and advanced threat protection are, well, game changers for managing risk.
Right, so it's tackling those core operational burdens. For the developers listening now, what features really stand out, the ones they'd use day to day?
Well, first off, the deployment options are really flexible. You've got single databases for, say, one specific app. Then there are elastic pools. Think of these as a shared resource model, great for lots of databases with unpredictable usage, like in a SaaS app, saves costs. And managed instances, these are key for migrating existing SQL Server apps with minimal changes. They offer near-perfect compatibility.
What about serverless? I hear that mentioned a lot.
Serverless compute is huge, yeah. It automatically scales compute based purely on workload demand and, crucially, pauses when inactive, so you only pay for what you actually use, down to the second. Ideal for intermittent traffic. And for massive data sets, there's hyperscale, supporting databases up to 100 terabytes. It kind of re-architects storage. Security-wise, integration with Azure Active Directory for logins, role-based access control, transparent data encryption, it's all built in, plus automatic backups, point-in-time restore, and easy integration with tools like Azure Monitor and Azure DevOps for your CI/CD pipelines.
Okay, that's quite a toolkit. So how does this translate into practice, like
Yeah.
real-world scenarios and any beginner tips?
Sure. So imagine a standard web app. You might use a single database, maybe with serverless compute, right? So it scales with user traffic and you're not paying for idle time.
Makes sense.
Or that multi-tenant SaaS app I mentioned. Elastic pools are perfect. Share resources across tenants, keep costs predictable, migrating an old complex SQL Server app. A managed instance is probably your best bet, maybe with geo-replication for DR.
And best practices for someone starting out.
Definitely choose the right deployment model first. Don't just default. Think about your workload. Serverless is great for spiky, unpredictable loads, but maybe not constant heavy use. Secure it from the start. Use Azure AD authentication, enable TDE, don't leave it as an afterthought, and monitor. Use Azure Monitor to track performance and Azure Cost Management to keep an eye on spending. It's easy to accidentally over-provision if you're not careful.
Right, cost is always a factor. Which brings us to limitations or maybe the gotchas. What should people be aware of?
Good question. Nothing's perfect, right? With serverless, that auto-pausing feature, it can lead to cold starts. A small delay the first time it's accessed after being idle might matter for super latency-sensitive apps.
Ah, okay. Anything else?
Well, hyperscale and managed instances, while powerful, generally have a higher baseline cost, so you need to size them right. Don't just pick the biggest option. Also, while managed instances offer high compatibility, single databases and elastic pools don't support every single feature you might find in a full on-premises SQL Server box. Usually not an issue for new apps, but could affect complex migrations. And finally, just be aware of, potential database size limits depending on the tier, like the 4 TB limit in general purpose, and that not every single feature might be live in every Azure region simultaneously. Just things to check.
Okay, so wrapping this up, the core message seems to be Azure SQL Database is this managed, scalable, secure process solution. It really lets you build modern apps without getting bogged down in the weeds of database infrastructure management.
Precisely. Understanding these pieces, the deployment models, the security tools, how to optimize costs, it really empowers you. You can build reliable, performant cloud solutions and keep your energy focused on innovation on the application itself.
So here's something to think about. With cloud services evolving so fast, how might these fully managed database solutions like Azure SQL Database continue to change the jobs of DBAs and developers over, say, the next 5 years? And maybe more importantly, what new skills might you need to stay ahead?